First of all, yeah, this is really to cover some of the more in depth on training. I was looking at IP particularly. Why are we going IP? And then a little bit about NDI and how that works. So, why IP in the first place? Well, the main issue with traditional routing and traditional infrastructure is that we had lots of constraints. So if you've been for an HDMI router or an SDI router or any kind of router, they tended to be a centralized router. You had to wire everything back to one place. So from a, just from an architecture point of view, it was always a little bit complicated. Every source, every destination has to go back to that place. They're quite often square routers, so you'd have 128 in and 128 out. That's not always what you want. Routers generally don't scale, so typically you put a router in and it stays the same size forever, and you can't really add another router to it because it's tie line based and it gets very, very horrible if any of you have done that. So you kind of have to overspec the router or the size of the router from the get-go, hoping the project's going to fit within it 5 years' time when it's grown and changed. Most routers also tend to be restricted to a format. You buy an HD SDI router, you buy an HDMI router, whatever, and you can only run through that router that signal because it's a monolithic, device, a black box designed to do that. And typically, they're proprietary hardware. I'm from a broadcast background, which meant they were from one of the broadcast manufacturers, of which some of which you will know, some of which you won't know, because it's a very small industry. So they're proprietary, and that requires proprietary control systems and a variety of different lock-ins. So really, we had to wait a while, though, before IP was good enough. That's the first thing. You couldn't have done this 10 years ago. It just wouldn't have worked. You probably couldn't have done it 5 years ago in the same way. So one of the reasons we stuck with traditional video routing is because it worked. But we've got to a point now where IP is, the computer people have caught up with us video people, which is good, well done. And we think their stuff's good enough to use now. And using IP gives us lots of advantages. So first of all, we can leverage the IT development curve. Turns out, I would imagine, well, if it's still true, they used to say that the whole of the broadcast industry was worse left than printer ink in the IT world. Now, if you've ever put ink in your printer, you know it's worth more than gold anyway, so I'm not sure how good how good that is. But, broadcast in terms of money is tiny. If you look at networking, how much money spent in R&D on networking, it's enormous compared to what, other industries are doing. And we want to steal that. We want to use that, leverage it, because it drives our prices down. It increases options and drives our prices down. So this term, we use it a lot, COTS, commercial off-the-shelf equipment. Rather than proprietary, we're trying to use and borrow equipment from the IT world. Now, one of the things that's lovely here, our hosts here at Netgear, they've done a great job in making low-cost switching available, high-performance switches available. But recently, they've one of the first large IT people to really understand that Pro AV is a market in its own right. And they've got a Pro AV line of switches, which are, using that general IT world, but actually focusing on some of the things that we need, some of the setups we need, some of the configs that are very specifically tailored to our world. So I'm a big fan of what Netgear have done there. I'm not just saying that because they're providing lunch, but they've done a really, really good job. But we couldn't do it if we weren't leveraging the IT, curve. Once you're in the IT world, once you're dealing with switches in that way, we can now have a distributed architecture. We can put the switches where the stuff is, simply put. So if I got 10 cameras somewhere, whereas before I'd have to run 10 cameras worth of cable back to my central switcher, I can now run those 10 cameras back to a switch locally in that room and run one fiber back where I need it. Really, really simple, cuts down your cabling. If you're wiring campuses, if you're wiring large buildings, it really brings down your cabling. And as we've talked of here, we're talking about power over Ethernet. It reduces your cabling and you're putting more stuff over that same cable. So it's, utterly a win-win. Format independent, it's just data. So we don't care what goes over it. It can be HD, it can be SD, 4K, 8K. It's just data. Switches don't care what's run over them. So we've got something that inherently is independent. Also, it's quite easy to upgrade switches. If you want to go for one with more bandwidth, you buy one with more bandwidth, or you put another blade in, or you do whatever's required. So it's a very efficient way of building a system in a, potentially in a non-linear way. And of course, a lot of IT stuff is hardware and software. When we're talking about our NDI technology here, it can be in chips, it can be in a software driver. Microsoft did a very quick integration and added NDI to Microsoft. To Skype. Added it to Skype, turned it on, and the next day NDI had 1.5 billion new users. Okay, so if you look around in your settings for Skype, you'll see an NDI section in there. You know, Microsoft bought into it, but so have Zoom, so have loads of other people, because software made that really easy to implement and really easy to develop. So IP is the way forward. So looking a little bit more about NDI in depth and how it works and how you set it up. I mentioned some of these earlier on, so I'll try not to go over it too much the same, but essentially NDI in that one cable brings us video, audio, metadata and IP. So video and audio, that's pretty straightforward. Metadata and control. So we can control cameras. We can do the PTZ control movement of the camera over that cable. You'll see the tally lights that we have, the red and green lights on some of the stuff that we have. That comes over that same cable. Everything comes over that same cable. So there's nothing else to do. It's very, very simple. With NDI itself, when it was designed, what were we going to do? Well, we wanted to make it work on existing gig Ethernet networks. So to give you an idea, at the low end, if you're using an HX codec, which I'll mention a little bit, you're talking about 15 to 50 megabits. At the high end for 4K video, about 200 megabits, 220 megabits. So it's really, really efficient in keeping 4K video working in a standard gig Ethernet pipe. Just to give you an idea, in case you don't know, if you're doing if you're doing 4K uncompressed, it's 12 gigabits per second. Okay, so we're doing that in about 200. So if you look at some broadcast systems, they're doing that uncompressed. So your switches get quite big. But also because it's, because it's a network, because it's IT, we can leverage higher bandwidths if they're available. So we will use 10 gig infrastructure if you have it. We can put lots and lots of signals over that size of infrastructure. It has to be simple and easy to configure. One of the problems with a lot of IP-based systems in the past has been you had to tell everything what the capabilities were of each device. You had to tell it where it was, what kind of device it was. You had to have a control layer that sat over the top. NDI has that built in. So when a device comes online, it says, hello, I'm a camera, I've got a video out, I've got an audio in, and I can do PTZ control. And everyone goes, hello camera, and now it's there available to everyone to use. You can hide it, you can group things, there's lots of things you can do to be a little bit more complicated, but by and large, the system is self-configuring, which is really, really important. Someone brings a laptop in, plugs it in, becomes an NDI device, everyone can see it, and away you go. It doesn't require extra configuration. Be interoperable. So NDI is designed to work across multiple versions, in theory at least. So you can have an old device, it should be backwards compatible across the versions, and that's because really NDI came out of one company. So it's not a standard that's multiple companies involved in, it's a single company, but that's really meant that it's stable and it's very easy to remain compatible. Working over long distances, we are now using different software tools to extend NDI over remote WAN networks as well. We can use a bridge server that can go between WANs and devices, which means we can control cameras in a different country or in a different office using the same protocols. It still keeps the system alive. It compresses it a little bit more to go over that long network, but it gets rid of the latency in the network and allows you to see any device anywhere based on, again, a group policy. So, if you've got a couple of offices, you might in your head office put your nice big vision mixer, but in your remote office in Sweden, you might have a green screen, a camera and a light and a tie clip microphone. You can bring that person into your production using the people you've got in London. So it's a way of just making your systems more flexible. So we'll talk a little bit about what we've got here, but really NDI will work on just about any type of video device. So cameras are fairly obvious. We've got cameras here from NewTek and from Salray and from Ava, all running different, actually each of them are running a slightly different type of NDI, all coming through the same system. But there are now thousands of devices out there that's running NDI. There are different types of NDI. So we have NDI for compute, which is CPU, which is just software. So anyone can register as an NDI developer, download the toolkit, and if you've got a program that accesses video, you can have it output as NDI. So VLC did that, most popular video player in the world. That supports NDI, for example, and it did it in about 3 hours. So, you know, if you are, I know some people are doing their own programming here. It's well worth joining up and having a play with it, because you can make things NDI very quickly. But also there are FPGAs available for embedding in hardware. So there's the Sharon camera there. It actually is called a Sharon camera, which is our South Korean friends came up with the product name. I'm from Essex, so that made me laugh anyway. And it actually has the software is called Sharon Finder, which sounds like a really weird version of Tinder. It's you know, that's using an FPGA from NewTek, so that's running their stuff embedded. Plus other people are running NDI in a slightly different version. The HX version is an H.264 codec instead of a DCT, brings the bandwidth right down, perfect for colleges and enterprises and people who want to, you know, run a lot of signals over a smaller network. And again, that's generally licensed and available in software and hardware on each device. And very quickly, I'm just going to show you how NDI works when we connect all this stuff up together. We start off with a network with a device on it. And another device, so one device looking for another device. And that device, first of all, uses MDNS, or Bonjour if you're an Apple type person, but uses this protocol out in the network to say, hello, I'm here. The receiving device then adds that product to its list and makes it available based on the criteria that it's got. So if I'm a vision mixer with an input and I select input, it says here are all the things that's got an output. So there's an intelligent mapping between how that works. Once that happens, a unicast port is opened so that we can set up the transport. And if we're using a vision mixer, something like a TriCaster here, a preview is sent at a relatively low bit rate, or a program is sent, program stream, the actual one that you're broadcasting, if you like, is sent at a higher stream when you're ready. So that means all of your little preview windows are taking up less bandwidth because you're only doing a thumbnail. And then when you hit, I want my main signal, it goes up to the larger stream. HX does something very, very similar, but here you see we go down from 200 odd megabits to about 15 megabits. So very, very, you know, very lightweight in comparison. There are 3 types of HX. We're showing 2 here, HX2 and HX3. So the AVa cameras are HX2, and the NewTek camera is running HX3, which is running at about 50 megabits, which is sort of optimized really for 4K use. So yeah, a few things to remember. So NDI itself is resolution independent. We can run anything from standard def up to 4K at all of the different bit rates, frame sizes and frame rates. Also, weirdly, NDI understands things like if you're using, no one here is a child, but if you're using your phone this way, or the wrong way, as I call it, rather than that way, that will work as well. NDI understands that you can have different types of video. Frame rates, you know, we go up to 60p, so you can do, you know, the highest frame rates out there. And it's, you know, it's completely independent. It can be set up and to have multiple types of format running at the same time in the same production. I'm going to miss a few of those. Just a few vendors that are working with NDI. Some names here that you all know. So, you know, I think it's a 6-year-old protocol now, and there are over 1,000, you know, products out there, and something like 5,000 developers running on it. It's a huge ecosystem. But what we're seeing now are, you know, all of the big companies that you know have NDI products. When you start seeing Sony and Panasonic running, you know, NDI, you know it's there. When you see Microsoft have added it, it's in Teams. There's an NDI plugin for Teams rooms and you know, how that works. It's just growing and growing and growing. A few things here. I do have to pretend that I'm here with NewTek, who are paying us. So these are some of their products. So I've talked about the switcher, the big thing in the middle. Their switchers start at, you know, £6,000 or £7,000 for a small one, up to, you know, 30 or 40 grand for the bigger ones. So really designed for any type of installation, any size. But they have products for Sparks, for getting video in and out of the NDI world if you want to go from HDMI or SDI or anything else in there. With a variety of cameras. Across the top there, bunch of free software. If you go to ndi.tv, you can download the tools and have a play with them. There's a free monitor. There's a free webcam driver. and you can actually start playing with NDI, all for free, just using Mac or PC. There's plugins for things like After Effects and Adobe. So, if you're using an Adobe Premiere timeline, the output can appear as NDI. So anyone can see the output or play out from Adobe directly live. Skype TX is a box for integrating Skype directly into a program. So if you want somebody to control multiple Skype calls coming in and play around with those, that box is great. We sold out when lockdown hit. We sold out every one of them we had in about 9 minutes. It was quite brutal. And recently launched, it's not on here, which we have here at the show, is CaptureCast, which is a NDI recorder designed to capture multiple streams of video in education and enterprise meeting rooms. So for education, if you've got a control system like a Panopto or something along those lines, and you're scheduling lectures, the system will be set up to capture maybe a shot of the lecturer, the laptop, an overhead camera, store that with metadata, either live stream it or record it and tag it and store it in the learning management system, and then play it back in a synchronized way so that the user can pick between which of the views that they look, either as a matrix or to pick the individual shot that they want to see. And that's, initially is literally just out, but it was aimed at the education market. But we've had a lot of people interested in recording training sessions in enterprise and also recording certain high-level meetings in that way as well. So yeah, the point with NDI, we think it's got a place just about everywhere. It's not just a broadcast product, and very much so. We found that AV integrators have done some amazing jobs and some really interesting customers using it in very flexible ways. And what we're seeing is what used to be a conference room is now a conference room / studio / production facility / huddle room, whatever, that gets switched around. IP is perfect for that. We can make this system look like whatever you want on that day of the week. 10 minutes to do something that normally takes 3 hours, but lunch is definitely on the way, and it wasn't my fault that we were late. So thank you for your time, but please come over and see us.